Okay. Oh, and by the way, our midterm for calculus, I think it will be third week or fourth week, the third week or fourth week of November. Okay. So after we finish chapter 4, maybe 1 or 2 weeks after that, we will have the midterm. So midterm will be chapter 1, 2, 3, 4. Okay. 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 Let's continue. Uh, okay. Some feedback from last Friday. Okay. Some feedback. Okay. Okay. Now the questions. The graph of f prime. Okay. So this you need to be careful. This is f prime. Okay. So this graph of f prime is shown. Local max at x equal. You need to find which one, and then I give you options here. Okay. So first, okay, before we look at the options, local max mean you have positive gradient, right, and a negative gradient, right? This is local max. Okay. So if this is f, if this is f, just f, then of course this will be your max, right? But this is f prime. Okay, this is f prime. So we are going to look at the slope is positive and becoming negative. So here is what I mean. So this will be positive, right? The y is all positive. This is the all negative. Okay. So from positive to negative, we look this positive, 0, negative, right? So here, so this is positive. This is positive. This is 0. This is negative. Okay. And then this is also positive, 0, and then negative. Okay. So that's why the answer will be x equal 4 and x equal 8. Okay. So because you already know the functions, the derivative, and also the second derivative, we will know that we are going to evaluate those also. Then if I, for example, from here, if I make the second derivative, you need to also can consider which graph will it's showing. Okay? At least roughly important point from the graph you can draw. For example, okay, for example, let's say here, if I have this is another slope, so this green color here will be a tangent to a tangent. Okay, you get it? Which means this the second derivative. So if I have another slope here, change of slope, so I can make another graph that is f double prime. Okay, we already checked last Friday with an example and how roughly we sketch. Okay, maybe it's not totally correct, but the important thing is you know which point that is important. The point that is important is the when you have this 0 here, right? Which means the second derivative will have something crossing that number. Okay? So if this is having slope here, having slope 0 means if you have the f double prime, it will have this is 1, right? So this is 1, this is 2. So at x equal 1, it's precisely 0. So we'll be maybe it's getting crossing here. Okay. Uh, how the graph looks like maybe it's having curve like this, or maybe going up like that. We are not really sure. But the important point is this 0 here. Okay, 0 and then 0, 0, 0, 0 for the second derivative. Okay. 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 So the answer for this will be this one. Okay, the x equal 4 and x equal 8. Okay. So be careful next time you see the graph. Read the graph carefully, whether it's f prime, or f double prime. Okay. Okay. The second question here, uh, the local minimum. So I think the idea here is we can check the f prime, right? So we can see, we can write this, okay, and f prime will be 1. This should be equal 0. And at x, so x will be 2. And then, okay, by the way, uh, if you feel the class is too fast, okay, please let me know. Okay, if the class is too fast. Okay, let me check the question. Okay. Oh, wait. It's wrong. 1. This is correct, right? And then, okay. Don't forget to make this uh, form here, because you have a domain exception here. So actually, you will have a hole in the function. So this will be, x will be 2. This x is, we call, if you remember, this we call the critical numbers. Okay. The critical numbers will be uh, f prime x equals 0. So every time you check f prime that is equal 0, the x itself we call the critical numbers. Okay? It's not always maximum or minimum, but whenever you find f prime, that will be our critical number. The x will be our critical number. Okay. But for this case, the x will be 2. Okay. Okay. Who's this student? Is there here? Is the student here? Oh, okay. 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 Please let me know whether you feel too fast in the class. If you feel not confident when you speak to me, you can write an email. And if you feel when you write email, you feel not confident because you need to write in English, don't worry, you can use Google Translate. You can use Google Translate, even though maybe it will be a little bit weird, but I think I still can understand. Okay, so even though you speak with broken English, also it's fine. It's fine. I will try to understand. Okay, don't worry. Okay, let's continue. I think some students are already like write an email to me like asking some question from the homework. Professor, I feel difficult this question, and then can you give me some clue? And then I give the students clue. Yeah, a few students they're already asking me like that. So that's also good. You can also ask me if you want, or maybe you have suggestions and you want to talk to me. That is also fine. Okay, last time we have arrived until here. Okay, so the difference between the two is we call this, okay, we call this is the concave upward, or so it's like a U, right? It's like a U like this. Okay. We call it concave upward, or if you want to simplify, become CU, it's fine. I think in some textbook or maybe some other reference, it's called the concave convex, like in the physics, convex, concave, but with lens, right? But I think just stay with the upward and downward, okay? Because maybe if it is different, then I think it will be also difficult to remember the upward and downward. I think this is easier, upward, and then the other one called downward. It will be an opposites from the upward, like that, or CD. Okay, so if we have this, okay, uh, so this means if the graph of f lies above all of its tangent on an interval, then f is called concave upward. If the graph lies below all of its tangent, then f is called concave downward. So what does it mean? So if we look here, okay, if we try to look at all the tangent, that is, we can see the tangent here, right? You can see that there is a gap, right, between f and the tangent. So the f is above the tangent. Okay. The other way around, if you look here, then it also have a gap, but now the tangent is above. Okay. It has a gap like that. Okay. So tangent is above the f, or f is below the tangent. So that is the definitions by words for concave upward and downward. Okay. Okay. If you look here, I believe this is not too uh, not too complicated to look at. We have concave downward for from A to B, from A to B here is downward, and then it's going to be a little bit shifted here, and it's become CU is upwards. Okay. So from downwards, and probably at around here at this point B here, it will shift it and it's become upwards like that. And also at the C, at here also, it also shifted and becomes downwards like that. Okay. So at this point B and C, we call this point an inflection point. Inflection point. And this also, this is upwards here. And again, this part here, whenever you have the shifted uh, shifted position, it maybe it's uh, the inflection point. But sometimes it can be also like this one. It's upwards and it's still upwards. This, we consider this to be like a local max, right? Like a local max. The f prime is undefined. This also f prime undefined. You can also consider this to be a local max. But remember that inflection point, the requirement for the point is to be when you derive second time, this should be equal with 0. Okay, so I hope you get the idea for the concavity, finding the concave upward, downward inflection point. Okay, I don't know, is in your high school, do you learn the inflection point also, or no, or learn, right? Okay. Yeah, I hope you don't mind reviewing uh, some chapters from the your high school. Okay, but now in the university, the difference between the high school and the university is in university sometimes you need to uh, the results, like for example, you have given the questions and you need to answer the questions with some maybe some numbers you need to calculate. University students, they need to get to the point where they need to understand and they can prove the answer is correct. Okay? A little bit different from high school. In a high school, usually you need just to answer the questions, right? Okay, this you have calculation. Oh, the answer is this, and that's it. That's usually high school stop at that point. But it's good if you understand how to prove, how to like finding or how to analyze the question. But university students, you need to be more like analyze the questions, analyze how you solve the problem. Okay. Okay, let me continue this part. Okay, concavity. Uh, okay. Let me just review first. Concavity test. This is uh, we call this concave upward. This is concave downward. This is on the same interval. Okay, on the same interval. Let's say on interval I. So the graph will be concave upward. The graph will be concave downward. And then by definition, uh, a point P on y equal f of x is an inflection point if f is continuous and the curve change from concave upward to concave downward, or from concave downward to concave upward. Then the curve change at P, okay, at P, or maybe at the end at P, at those points. Okay. Let me give you an example here. Uh, discuss the concavity inflection point and max mean value. Actually, this is the graph, but let's just start with the x with power of 4 minus 4x cubed. So whenever you find functions, and then you need to find concavity, maximum minimum value, inflection point. First thing you can do is you can analyze from calculus. Okay? Analyze from calculus, which means you can analyze from the functions, and then you can derive. At least you can have this form. Okay. And then you can take this to equaling 0, and I think we can factorize. And also, you can also look at the second derivative. Okay, now from here, we get that, maybe we're going through here. Maybe from here, we get x equal 0 and x equal 3, okay, for the critical numbers. So if you are asking the critical numbers, this is critical numbers. And then you get x equal to, this will be your inflection point. Okay, both of this you can check with the line number to see positive or negative. Maybe giving this maybe 0 and 3, and checking number here, checking number here. Maybe checking number 1. What will be? It will be negative, right? It will be negative. It will be negative here. Checking uh, checking negative 1, it will be positive, right? It will be positive here. It will be positive. So this will be going there and going there. So this will be max. This 0 will be max, and this will be min. You can also look this, and if you need to find the value, you can plug in 0 and 3 and find the value. Okay. And this part here, you can also do the same thing. 2 is there. And then this will be negative. This will be positive. So what does it mean? Negative means your f double prime or second derivative is less 0. This means positive like that, which means this will be concave downward, okay? And this will be concave upward, okay? Inflection point also 0. I forgot to mention 0. So maybe here we take. Okay, I forgot to mention 0. If you have negative, it will be positive. So this will be another concave upwards. So 0 and 2 will be the inflection point. And now, carefully, we can at least sketch, okay, at least graphing from the inflection point and then the critical numbers, and put those in here. Okay. So first we can make 0 here. Okay. We can make it this is 2. Okay, 0 and 2 for the inflection point. The critical numbers also we have 0 and 3. So yeah, I think this is 3. Yeah, this is 3, this is 4. Okay, this is 1. Okay, 0 and 3. And we can also have concave changing from here. This is changing from upwards and changing to downwards. Until here, we still have, and then change to here. Oh, I think wrong here. This is not max, right? If you put -1, it is negative, right? Okay, negative, sorry. So still negative, and that is true here, is negative, and then also negative here. Yeah. Okay, first, to graph this, you can maybe mark the all the important number, that is 0, and then 2, and then 3. Okay. And then from infinite to 0, you can start by graphing the at least the slope that is negative, like that. Okay. And then you know also from the inflection point that is from the negative infinity to 0, this will be concave upward. So it should have looks like this. Okay. It should be like this, right? And then from 0 to 2, it will be concave downward. And you have a negative slope. So you should have a different and making a different in the shape of the graph, like that. Okay. Okay. And same way up until here, you get 2 here, and then you need to have another concave upwards. Okay, concave upwards. And this 4 here, you can actually look for the intercept. Okay, so the 4 is called the intercept. So you can check whether the function uh, has a root or no. If the function has a root or no. If there is a root, then it should cross the x. Okay. 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 Let's try another example. Okay. Maybe yes. Okay. Any question, or is there any mistake that I make? Yeah, there is no max value. If you look at the graph, it's going down, and then we have the minimum value here. If the question is not really mentioning any local or absolute, you can just say minimum or max. And then that's still okay. Unless the question specify whether there is absolute or local, you need to mention the local or absolute. Okay, let me continue a little bit. Uh, okay, this is just to review the previous one, second derivative test. Uh, you can actually, by looking at the inflection point, you can check whether it has a local minimum and maximum using the second derivative test. Okay, and concavity test we have done previously to determine whether the function has concave upward or downward. Okay, concave upward or downward, like that. Okay, this is uh, an example from the textbook. Sketch a possible graph, satisfy the conditions. First, f prime is greater than 0 on negative infinity, to 1, and then f prime is less than 0 from 1 to infinite. So we can design in a line number like that. And this is 1, maybe in the middle like that. So f prime x is greater than 0. So this will be going up. The slope is going up. And then the slope is going down from here. And the second one, you have negative 2 and 2. So the second derivative is positive. So positive, and then negative, and then positive. Meaning this will be concave upwards. This is concave downwards. This is concave upwards. Okay, and then we have a limit as x approaching negative infinity, you have negative 2, which means this will be our asymptote. Okay, will be our asymptote. Okay, asymptote. And when x is approaching infinite, you will have 0. So this will be how you draw the end behavior of the graph from the x to infinite and x to positive infinite. Okay. Okay. So first we can design from the first statement and second statement. Okay. Designing how the curve will be. Okay. And not necessarily to be if you draw, as long as it mentions all necessary statement, I think that should be okay. That should be okay. Not necessarily to be correct all the points, okay? But at least you can make sure that it has the concave upwards here, downward, upward, and then you have I think a maximum value here, okay, at 1. So let's try to make that function. Okay, so we know that this negative 2 and 2 will be our inflection point. So maybe we can start by mark all the necessary. I think we can make it bigger, maybe here. Okay, so at negative 2, 2, 2, there will be a concave downward. So we can make it and imagine that this negative 2 here, and we have 1 as our maximum value. So it's probably going here, and it's going down like that. Maybe not really touching this, maybe, okay, maybe like that. Okay. Because from 2 to infinite, if you remember here, we need to have a positive. So this is downward, so it should be having another that is upwards like that. Okay. But we have limitations. Okay, we have limitation of the asymptote. Okay. So if x is approaching infinite, the limit value will be 0. So when you have this, it wants to go up like that, upwards, but it has this limitation, so it should be like that. Okay, it should be going to be approaching the x-axis. So like this, or maybe to be making a little bit smoother. Okay, like that. Okay. So I hope you can see that this is downward and then it is upward. Okay. Okay. And then from here, this -2, I think it's not really here. If you check, uh, maybe a little bit going here, or if you want to make sure, you can check the if there's uh, anything that is making 0 at the functions, but we are not sure, right? But what we are sure is this -2 is this inflection point. So maybe we are going to have maybe around here. This is downwards. It should be upwards until this is 1, this is 2. So you have another asymptote. Let me draw the asymptote. The asymptote, maybe here. Or maybe let me draw with line. Yeah, I think this will be better. Okay. Now, if you look here, it's also upwards, and then maybe at this point, okay, inflection. Okay, not necessarily to be smooth, but I think as long as you nail uh, the necessary thing, concave upwards, downwards, upwards, you draw the asymptote. Okay, you can see that it's actually getting closer to this value. Okay, when you have x approaching infinite, and when you have x approaching negative infinity, you have an asymptote. You can also see the slope changing, a positive, negative. Then I think the graph is okay. The graph is okay. 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 Whenever you have, maybe sometimes I will give you some, maybe a little bit homework. Just a few questions to make sure that you understand the graph. If the question needs you to draw, you don't need to draw really like smooth, but as long as you mention the important point of the graph, like in calculus, okay, I think that should be okay. Okay. The thing is, what you learn this chapter is actually will be very helpful when you think some graph. Maybe you have later difficult functions that you have, and then you want to at least graph the functions, or you want to see the visuals from the functions. If you want to directly see, then you can do the some derivative, first derivative, second derivative to see how the graph will be. But of course, if you have uh, like the graphing device, I think maybe in your you have some software, or you can go to the some website to just draw the graph. I think you can do that as well to make sure to confirm to check the graph is okay or not. Okay. 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 Any questions? Any question from the online student? Okay. Okay. Some of the international student I think already arrived, right? Okay. Oh, I just show the. Oh, Maria. Okay. And you show the attendance. Okay. Later at the near the end of the course. Okay. Okay. Okay, any question from here? No? Okay. Uh, okay, this is another review here. We can skip that. I think we already have arrived at this conclusion. Let me give you another example, and then make a conclusion about the curve sketching. Okay. Let me give you an easy example. Okay, easy example. Let's start with the cubic x cubed minus x squared. Okay, find max, mean value, concavity, and then is there any inflection point? And then after this, I will go to conclusion on how we sketch a graph, and I will give you another example. Oh yeah, by the way, if the question asking max mean value, and the question not necessarily providing you, is it finding just the x or finding the whole value? That means you can do both. Okay, you can do, maybe you can check, okay, maximum when x equal blah blah blah, or minimum when x equal blah blah blah. Not necessary to check the total value. Okay, because I think if you check one by one, you need to calculate, right? And then it takes time. Okay, if the question is not really mentioning that, you can just answering maximum value at x equal some number, minimum value at x equal some number. Okay. And after you got all this information here, try to sketch roughly the graph. Sketch roughly f of x. Okay. So probably you first going to check the f prime and check f double prime. Can anyone try to sketching the graph? And because it's also a simple functions, cube functions, if you remember the behavior of the cube, maybe you can predict how the graph will be. Okay. At least from this f prime, we can check. So we have the critical numbers is 0 and 2/3. We can check the 0 and 2/3.
To the left. What are you doing?
What are you doing?
Keep going to the left, bruh.
Keep going to the left, bruh.
Babe, I'm playing a game. Why are you doing that?
Why are you doing that?
This will be negative. This will be positive.
You just wipe it away?
No.
And this will be having the x equal 1/3. This will be our inflection point. Let me write I the inflection point. And 1/3 there. This will positive. This will be negative.
I want you to learn to dance with me.
So this will be concave upwards. This is downwards.
I can't remember how it
But
goes.
you just give me that dry kiss for if you was gonna wipe it off.
What do you mean?
I just saw you. Like wipe it off.
Wipe it off.
Okay, so okay, any question from the online students? Any question? No. Okay. Okay, now we have this. How do we know if it is upward or downward from the x values in f prime? In f prime. Okay. So if you have, okay, Laura, if you have f prime here, like for example here, let's say this is f prime. Okay. So if this is f prime here, okay, Laura, you will know if you have the slope here, this means the f double prime is 0, right? This is also f double prime is 0. This is also f double prime is 0. Okay. Then you know that this will be positive, right? Positive slope, which means this is f double prime is greater than 0, which means this is concave upward. And we have negative here. So at this point here, this is f double prime is less than 0 or concave downward. Okay. Now, if you want to draw and make it into what is the original functions look like, so probably let me write this a little bit lower. If you have another, so which means you will have this point here. This will be your inflection point. So this will be your inflection point, and this will be concave upward. So probably it will be looking like that. So we are not really sure the other point, but at least it looks like that. Your F, okay, it's concave upward, right? And then it will be downward after you get the inflection point. or maybe like that. Maybe like this. Okay. If we don't have the graph, yeah, if we don't have the graph, then you stick with the f prime greater 0 is concave upwards, and less 0 is concave downwards. We stick with that definition. Okay, we stick with this definition. Okay, so if you have like f prime and you would like to know what is the original function, we can check using uh, the derivative of the f prime, which is the second derivative. Then we can see the slope here, the slope of f prime, the slope of the slope, right? Slope of the slope. So we have this is going to be positive slope, which means this is the second derivative is positive, which means positive means it's the concave upward. So up until here is concave upwards, and it's going down, and this will be concave downward. So probably you will have like concave upward like that, and then going to be downward. And then we can continue and make another function as well. Yeah, but I think this is wrong, right? Should be it's going to be up. Yeah, I think maybe because we don't have any more information. Okay. Okay, back to the question here. Okay, so we have the critical number 0 and 2 over 3, and also the inflection point is probably 1 over 3. And how we can draw the graph, we can draw first maybe making this is -1, this is 1, and because it's having 2 over 3 and 1 over 3, maybe it will be here and here. This will be 1 over 3, and this will be 2 over 3. Okay. Now what will be? Okay, what will be? So from 0 to 2 over 3 here, so 0 and 2 over 3, this will be our critical numbers. And this will be from positive to negative. So there will be a slightly going up at 0. You can also check the original functions f of x, x cubed minus x squared. When you check this, if you get a negative number, maybe -1 here, what will it be? It's 1, it's -1, it's 0, right? So it should be -1 cube, -1. It should be -1, negative, plus 1. Or if we are going to look at, this should be x squared minus 1. So x is 0 and x is plus minus 1. So until here, this should be it should be going here, and it should be going up. Okay, maybe it's going here, going up here, and going up like that. Okay, let's see. Oh, wrong here. Sorry. Okay, yeah. That's why I don't have any roots in -1. So it should be going to be. Okay, so sorry here. I think going. Yeah, I think this will be better. Yeah, this is to be correct. Okay. Sorry. Okay, so first, if you can find the intercept here, so we can say that we can have intercept is 0 and 1. So that will be meaning the curve will be crossing that point or touching that point from the function. And then from the -1, from the -1 here until maybe 0, we will have a positive slope. Okay. So if you are using, maybe you draw with pencils, you can draw maybe the slope first. You can draw the slope first. And then after that, see the concavity. When you have this is the downwards concavity, then you need to have until 1/3, maybe around here. You need to maybe going like that. Okay, going there, like that. And then from 1/3, you will go upwards. Okay, you go upwards. And then check this 2/3 here. When you go upwards, make sure you go upwards at exactly 2/3. So 2/3 can be a local minimum. Okay, because it's negative, positive is local minimum, and make sure this also 0, a local maximum. Okay, 0 local maximum. This is intercept. And this is inflection point. Okay. Yeah, I hope you get the same, a similar result with me. Okay, like that. Okay. Okay. Let me give you a little bit conclusion about the sketching curve, and then I give you another example. Okay. Let me give you the conclusion first. So curve sketching. So first, okay, always consider domain. Okay, always consider domain. So first domain. Second, see if there is any intercept. Okay, x-intercept or y-intercept. See if the function have or no. And then see if the function is symmetry or no. Symmetry. How to know the symmetrical functions? We know that from the odd or even function. Okay. If you have odd, you will have asymmetrical. If you have even, you have asymmetrical functions, right? Okay. And then you can also think about the asymptote, whether it has asymptote or no. And how to find the asymptote, you can use limit. The first asymptote, maybe the x approaching infinite or positive infinity, and it has some value. This will be y equal L. This will be our horizontal asymptote. Okay. Oh, let me write complete the horizontal asymptote. And if you have limit x from a from the left or from the right, okay, can be checked of f of x, and it will if it is infinity or negative infinity, then this will be x equal a will be a vertical asymptote. And then check the increasing or decreasing interval. We know this from the first derivative, right? From the first derivative, check the slope, which slope has negative or which slope has positive. Okay. And then check the local max or local mean. Which means this can be checked by a critical numbers. But remember, critical numbers not always necessary to be local max or local mean. We need to check whether the critical numbers have changes from positive to negative or from negative to positive. This we call max. This we call mean. Okay. And then the last, not last, maybe concavity and inflection point. So remember, you have f double prime x greater 0. This will be concave upwards. If you have f double prime less 0, it's concave downwards. And if you have f double prime equals 0, then it will be your probably your inflection point. And then if you have all this information, you can try to sketch the graph. Okay. The previous example is just a simple graph, cubic functions, not necessary to be the domain is all real numbers, right? And I think there is no necessary asymptote, so you can skip a few parts. But if you have, for example, a rational function, one maybe x squared plus blah 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 over x plus 1 or x plus 2, of course there will be some domain that you need to have some exceptions, right? Maybe you need to draw a hole, right? A hole, and then maybe you need to draw the asymptote. Okay. But I think all this, okay, already summarized into 1, 2, 3, 4, 5, 6, yeah, 7 points that you need to be taken care of when you try to sketch a graph using a calculus, okay, using from perspective of calculus. Okay. Okay, let me give you the example. Okay, that you need to at least think from all this point. From all this point. Let me give you the example. To sketch the curve. Okay, the question is just asking you to sketch the curve x divided by 1 plus x squared. Of course, you can check if you can open the graphing calculator. You can check. And I think if you use smartphone, also you can. I think you can download the apps. Maybe GeoGebra. I think there's also the app, GeoGebra or Desmos. Okay, if you have a tablet, a smartphone, you can check. If you want to draw in your device. And also for your quiz, actually, if you want to prepare some notes for your quiz, that's okay. That's okay. That's okay. As long as you have time to prepare, because it's just a quiz. Okay, it's just a quiz, so that's fine. But if you want to try challenge yourself, try to work it alone without notes. That's also fine. That's also fine. Oh yeah, for international students, I hope you can come before middle of December. If you read the news, because we will have a lot of movements during uh, Chinese New Year, so the government will put some restrictions on, I think, December, middle December. So I hope international students, you can come before middle of December, because I think from December 14, the border will be closed until, I forgot until when, maybe February or January, maybe February, until February. Okay, if you want to check the domain here, 1 plus x squared is always positive, right? So no need to be worried about the domain. So it's all real it's all okay for all real numbers, right? So 1 plus x squared is always positive. So always positive. So the x value is on all real number. So check domain. Actually, you can go like not necessary to be put all the information in order, but actually you can do with from anywhere you want. You can check the f prime first, or you want to check the f double prime first. It's okay. So intercept. So when x is equal 0, f of x is also 0, right? So 0, 0 will be the intercept. So this will be the intercept. And then check the symmetry. If you want to check the symmetry, we can check the negative x. We can see that this is actually negative fx, or we can conclude that this f of x is a symmetrical function. Symmetrical. So asymmetric means maybe like this, or maybe like this. Okay. Let me give you a few minutes and check whether you can draw the functions or not. Okay. Anyone finish drawing the function? Okay. So for the asymptote, if you look at the functions, x over 1 plus x squared, I think there will be no vertical asymptote, right? Because it's always positive here. So maybe we can observe the horizontal asymptote. Okay, so asymptote we can check with limit. Okay, when x is approaching uh, infinite. Okay, x 1 plus x squared. This will be directly, if you see, this is degree 1, this is degree 2, so it should be 0, right? Okay, it should be 0, directly 0. So y equals 0 will be our horizontal asymptote. If you want to check the x to negative infinity, also you can do, and it has the same conclusion. It's 0. Okay, so horizontal asymptote. Here, horizontal. And then we can check uh, the first derivative. Okay, so a bit here. So this will be 1 minus x squared. This will be 1 plus x squared. Okay. If this should be equal 0, if this equals 0, then okay, whenever you have a rational function here, you need to make something 0. Okay, this is just a review. Then the one that is responsible, just this, right? Okay. So you just think about this 1 minus x squared equals 0. So x should be equal 1 or negative 1, right? So this will be, let me write here. And then maybe we can look at first the -1 and 1 as our critical number. Okay, so this will be critical number. This is critical number, C numbers. Okay. And then check, this will be positive, this will be negative. Okay. So this will be a minimum value, this is the maximum value. Okay, now check the second derivative. This is a little bit, I think, long. So 1 plus x squared is 4. And then negative 2x, 1 plus x squared. And minus 1 minus x squared, and then 2, 1 plus x squared, 2x, right? So this will be, let me just write one by one first. Yeah, is it correct? Factorize this out here, and then we'll be having minus, minus. Okay, I think correct, right? Okay. And then we can cancel this with this. And if we want to make this so this will be the result from here. Then we can write this 2x cubed minus 6x. Okay, at least we have this, and we need to make it equal 0. So we can have 2x cubed minus 6x equals 0. Then x will be x squared minus 3. So x equals 0, or x equals square root of 3 plus minus. checking the inflection point, checking 0. Oh, sorry. Should be having 3. Square root of 3. So 1 will be a negative here, a positive. Oh, it should be also positive. Negative 1, negative 1, 1, negative. Yeah. Negative 2, 4, negative. Okay. This will be having concave downward, concave upwards, concave downward, concave upwards. Okay, but the real solution is not this, right? We need to sketch the graph. Right? Okay. In my second derivative here, is there any mistake, or you find a different answer from here? The second derivative, the same with you? It's okay here? Have you checked? Okay. Okay. Okay, now let's draw the graph. I need to take another slide. Okay, and we draw the graph. We need to make a graph that has -1 and 1 for its minimum and maximum, and also the square root of 3. Okay, square root of 3 maybe around here. Okay, maybe here. So 0 to not 0, sorry. This will be concave downwards. This will be concave upwards. This will be concave downwards. And this will be concave upward. Mean at x equal -1, right? And max at x equal 1. Or you want to write local. And asymptote is y equals 0 at the x-axis, right? So this is y equals 0. This is the asymptote. Okay, now let's start with the intercept is 0, 0. This is the intercept, so the graph should be crossing this, right? So checking, this is inflection point here. So probably this will be having a minimum. So maybe let me write. Okay, and now we need to change the concavity. And change the concavity. And the graph should be asymmetric. So this should be, if you flip here, it should be identical. Okay, it should be identical. Okay, so this will be the graph. Okay. If you want to be more specific, you can check F1 and F-1, which uh, this value here you can check. Should be identical, should be the same, but I think I make too long here, but okay, yeah, but at least the 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 process and the results should be at least like this, okay, at least like this, okay. 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 Any questions related to the sketching curve before we go to uh, the feedback time? Okay. So next Friday, I still review this part. Okay, review this part a little bit, and then go to the next section is about the L'Hopital rule. Okay, the L'Hopital rule. Okay. I think L'Hopital rule also teach in high school, right? High school. Yeah, because I remember I also do L'Hopital rule in high school. Yeah. Okay. Okay, but before we go to feedback time, let me give you some questions that you might to check at your home, and we can discuss next Friday. The first is sketch the curve. And I will give you two functions, or maybe just directly write f of x and g of x. Okay, check these two functions. Okay, first you can try to I think you can try from this f first. You can try from this. It will be similar, but it will have an asymptote, right? You can try from here. Check with your calculus. Plot the graph from this, and maybe you can check compare with your graphing calculator. You can check the website how the graph will be. And second, you can check the g 1 over x squared minus 1 over x minus 1 squared. Okay, check this. This the right part here, I think it's a little bit more difficult than the left one. Okay, but check, okay, check with your own. And then I will discuss this next week. Discuss this next week. Okay, any questions from the online students? Any questions from the classroom? Any questions? Maybe anything to discuss with? If no, then we can stop the lecture, and I will give you the question at the end of the course. So, okay, actually, this semester, I just started using the QR code scanning for some questions, some feedback questions. This is just to help me whether at least you recognize the concept from today's lecture or maybe some review. Okay, because previously, like last year, uh, if there's students who are not really doing well, and I'm not sure how many like they understand or not, uh, and I keep moving, and the students maybe feel a little bit like, oh, I need to catch up, but maybe they cannot say anything, they couldn't say anything, and I don't know the students as well. So that's why I decided to make some feedback questions. So I know how many percent, at least maybe half or maybe a few of you maybe still need to review, and I will review that part until most majority of class. Okay. Of course, I cannot help you if you are maybe like a little too far from the understanding the concept. That is difficult for me. Like for example, if students need to have more concept in basic of math, like the fundamental mathematical like concept, I cannot help you really well because I need to move forward in calculus. Okay, like for example, like algebra. Okay, uh, like the algebra here, anything related to geometry that you need to know beforehand. Okay, uh, then you need to review by yourself. Okay, review by yourself. Unless you can maybe email me which part you are really not sure, I can give you a pointer or some reference that you can look up and maybe which part that you need to learn before. Okay, let me start with the uh, feedback time. Okay, so this will be stop here. Okay, the review here is specifically for the second derivative in a sketching curve. Okay. Yeah, I think because today most of our life is a digital life, right? Like a social media. You have also like usually watching something on digital platform, right? Like YouTube, like Netflix, maybe, right? So I think digital also can help our study, right? I believe uh, you can also look for reference on the internet also. Okay, okay, let's start. Let's start. Okay, online students, if you join here. Okay, okay, let's go. Okay, okay, are we ready here? Okay, 3, 2, 1, let's start. Okay, carefully read the questions. Okay, carefully read the questions. Okay, I hope 1.5 minutes is enough. Okay. Okay, time's up. Okay, good. Okay, good. Okay, next section. I hope you don't mind the sound. I don't know why. Wow, really close. Okay, okay, 3, 2, 1. Okay, start. Okay, I hope it's enough. Okay, you can carefully see the X value. Okay, careful. Okay, 3, 2, 1. Okay, okay, 0 to 3. How many of you get correct? Okay, I think quite a lot. Okay, okay, last question. Okay, last question. Okay, 3, 2, 1. Okay, I have 2 minutes. 2 minutes enough. 2 minutes enough. Okay. Okay, 20 seconds. Sure, if you can open the graphing calculator, you can graph and see the inflection point. That also can do as well, if you want. 3, 2, 1. Okay, that's up. Yes. Okay. 3. Okay. Okay. Okay, sorry, I'm late. Okay, sorry, I'm late. Okay. Oh, still. Who's number 2? Who's number 2? Okay, okay. Okay. Good. Okay, that will be the end of our course. See you next Friday. And check the quiz. Don't forget, check the quiz and check my last 2 curve for sketching the curve. Okay. Okay, see you next Friday. Yeah, you're welcome, Paris and Ardian.